everybody. My name's Hillary Brindley, and I am doing the Euler line. I'm doing a demonstration on how to find the Euler line. Basically, the Euler line is in any triangle, the centroid, circumcenter, and orthocenter always lie on a straight line, which is called the Euler line. I have up GeoGebra here. I'm going to start by just removing the axes and the grid. I find having a blank canvas to work on without all the lines and extra grids is helpful for this particular demonstration. So I'm going to start by drawing a polygon, just drawing a triangle using my polygon tool. So I'm just going to draw a really like that polygon, and then I'm just going to do this. I'm actually going to change the color of this as well to kind of make it kind of lighter, transparent, so it's easier to see. The first thing you want to do is you want to find the circumcenter. The circumcenter is you want to find the midpoint of each line segment, then draw a perpendicular line for each midpoint, and then the point where the lines intersect is called the circumcenter. So we're going to go ahead and find that. When you're using GeoGebra, you can just use this fancy little tool called the perpendicular bisector. And then if you just hit on each line, it'll draw a line for you. And if you can see here, this is called the circumcenter right here. So I'm going to go ahead and make a point where the lines intersect. Now we're going to have a bunch of lines going on, so I'm going to go ahead and try to change the color, and I'm actually going to do dotted lines just because, and I'm going to make it purple, just because it's really hard to visualize and try to deal with all the lines that are there when there's so much going on at one time. And I want to change the color of this like that. All right, so there's our circumcenter. The next thing you want to find is the centroid. You want to find the median of each vertices. So you want to find where each point, the midpoint of each line connecting it to each vertice, which we've already found when we found the circumcenter. So this portion is also very simple. So we'll go from D to D, A to A, B to B. All right, and if you see here, this is our centroid. This is the center of our triangle. So again, I'm going to find my point where the lines intersect, the intersection point is here, and I'm going to change the line to a dotted line and change the color as well. So I'm just go ahead and change the color of all the lines while I'm here, the color, and now I'm going to change the lines, the rest of them. And then there you can see the line of the centroid, or the point of the centroid. The next thing you want to find is the orthocenter. You want to find the altitude of each vertices, draw a perpendicular line, and then where all three lines intersect is called the orthocenter. Alright, so what I'm going to do is this is also a fun little trick, is you're going to construct a perpendicular line. You're going to go from point D to this line over here, and then that'll draw your perpendicular line. So B to line B, point A to line A, like so. And then this point right here is where those lines intersect, and this is called the orthocenter. So I'm going to do my point of intersection right here, like so, and I'm going to change the line / colors of each. I'm going to do a lime green color, feeling Eastery. The point. Change the lines. Okay, now if you can see here, there's 3 points of intersection here, and if you can tell, they're going to be all on the same line. So this is what will be called our Euler line. So I'm going to go ahead and draw a line, and all I have to do is push these points, and you can see, so these 3 points make the Euler line, and I'm going to make it a little bit darker so the line darker, so that way you can see that those are on the same line. And there you have it, the construction of the Euler line using GeoGebra. Thank you. And